4.2 Convection. The manufacturer says this ceiling fan, when rotating in reverse direction, can warm us in winter. What do you think? We learned from the last chapters that liquids and gases are usually poor heat conductor, but heat can still transfer inside liquids and gases, and in most cases even faster than heat conduction by metals. This is done by convection. Experiment 4b. Convection.
Gently warm the water with a small Bunsen flame. Carefully put a purple crystal into a beaker of water near the side. Observe the movement of the colored water round the beaker.
A candle is placed inside the beaker as shown. Light the candle and place a piece of T-shaped cardboard across the beaker. Hold a piece of smoking paper on the other side of the cardboard. Watch the movement of the smoke. We can also study convection of air using a spiral foil. Light up the candle. Observe the movement of the spiral foil. How does the foil move?
The experiment shows the convection currents in different cases. In all these cases, you can see convection currents form closed loops. 1. Convection in liquids and gases. Convection current starts from heating one part of the liquid or gas. The fluid there becomes warmer and expands a bit. The density decreases, and due to gravity, it rises. When it rises, it loses heat as it mixes up with the cooler fluid. Eventually, it cools down and sinks later. Almost at the same time when the hot liquid rises, the colder liquid just next to it replaces its position, completing the convection current. Such convection current transfers heat directly, as energetic molecules travel directly from the heat source to the other parts of the fluid. Usually, heat transfer by convection is more effective than conduction. The same mechanism also applies to other two setups of the above experiment. 2. Examples of convection. A. Convection heaters and air conditioners. Convection heaters are best placed on the ground, while air conditioners are best mounted near the ceiling. For the convection heater, it first heats up the surrounding air by conduction. The warm air rises as they expand, and their density decreases. As cold air near the ground replaces the air around the heater, the convection current is completed. For an air conditioner, it blows out cold air, which almost immediately thaws. The warmer air on the other side of the room rises and eventually sucked in by the air conditioner, and the convection current is completed. B. Sea land breezes. If you understand how convection currents were set up by a heater or an air conditioner, you should be able to explain the formation of sea land breezes. The picture here explains the formation of sea breezes, which is wind that blows from the sea to the shore. During daytime, the sun shines on the land and increases its temperature, as sand and rock have a smaller specific heat capacity than sea water. The air above the land is warmed up by the hot land, and the air rises. The cooler air above the sea replaces the hot air above the land and produces an air current from the sea to the land. The convection current is completed as the rising warm air cools down and sinks over the sea. C. The shape of a candle flame. You should be familiar with the shape of a candle flame. A flame is hot and the surrounding air is heated up easily. The air expands and its density is reduced. It rises and cold air in the labeling moves in and replaces them, creating a convection current eventually. D. The high position of extractor hood. Extractor hood, or ventilation fan, is often high in position as hot smoke and steam rises during cooking. E. Water heating. Immersion heaters are found not only in physics laboratory, but also in water heater such as electric kettle, shower heater, and even fish tank. Immersion heaters are often placed near the bottom, as it may then create a convection current that can help heat transfer within the water body. Example 2. Why do recoil on the ground during a fire? In a smoke-filled room, the hot air, including the smoke, rises and flows upwards. The air near the ground is a bit cooler, and there also accumulates a little bit more oxygen. Avoid breathing in hot air may reduce the chance of lung injury and infection, which can be lethal. Example 3. Using air to keep warm. A layer of air may keep us warm, and that's why we put on clothes. A tent traps a lot of air, but it does not keep us warm easily unless we first heat up the air inside. By the way, why a down jacket is so effective to reduce heat loss from our body. Read Part B carefully. Example 4. Ice cream fondue. If you order a takeaway ice cream fondue, you may wonder why the ice cream does not melt so quickly. The example tells you the physics behind. Do check point 3 on the next page. And don't forget to read the supplementary information, Air Conditioning System in Zero Carbon Building, on page 117, as well as the explanation of warming with a ceiling fan on page 113.